Welcome to Coding with Tom. Today we're going to create a WatchOS app that will integrate with our existing castles app. We'll be able to attack and fortify castles from the WatchApp. We'll also be constantly syncing the information so that every change that occurs in the app will be reflected in the Apple Watch. Because the WatchApp is going to be exactly the same for both applications, we're going to consolidate adding the WatchApp to the UIKit and SwiftUI implementation in one video. So the first thing we have to do is add a target. So we select WatchOS and we add a WatchApp for an iOS app. Since it's not going to be an independent WatchApp, it's going to be synced by the iOS app. Unlike the iOS app where we do it both in UIKit and SwiftUI, for the WatchApp we're just going to use SwiftUI. We'll activate the complications, but we're not going to do anything with it right now. It's just for a future video. First, let's create our view. So we're going to also have a dashboard view in our WatchApp. Here we're just going to display the amount of gold and a list of the castles that we have. We will also have a dashboard view model. Right now we're just going to expose the gold, and later on we'll add the castles. Before we keep implementing, let's share some resources from the iOS app so that we don't have to create these classes again. So that'll be the castle and the kingdom model and the currency presenter, which we use to display the gold as a string to the user. For the XE assets, we do have to drag and drop again the images. Now these images were not optimized for watch, so we're going to just add a fixed width and height. For now, let's just display the castles as a list of strings. Let's use a for each and see what we have. Now we have our list of text, but it will be best if we have just a simple raw period. Since we're not going to do anything fancy here, we're going to use list. Now, besides the name, we will also be showing the attack and defense of each of the castles. The name, attack, and defense of the castle will all be included in a view model that we'll receive from our dashboard view model. And now our view is ready to display the information in the view model. What our view model is missing now is reacting to the user's actions. So that is when the user chooses to attack or fortify a castle. And now we're going to be needing use cases. Just like we did with the iOS app, we're going to have use cases to perform the player actions, either attack or fortifying with a castle. It will take a castle ID that's performing the action. And our source of truth will be publishers. Now, instead of the view model being the one that mocks the data, let's move these mock view models to our get castles publisher adapter. The other source of truth that we need is a get gold publisher use case to retrieve the gold that the kingdom has. With our use cases ready, let's just add them as dependencies in our view model. We'll call the execute attack and fortify in their corresponding methods, and then we will listen to the publishers. For the gold, we'll just format it with the currency presenter. And for the castles, we do need to keep a reference to the castles since the player will be selecting them for attack, and we need to know the ID. Let's do a little bit of cleanup in our view. So the row we will not create it in the body. We will have a view builder function that will do that by taking a castle view model as a param. Here, instead of complicating ourselves trying to find the ID, let's just tell the view model that we tapped on a castle at an index. Then, in our view model, given that we do have the player castles, we just match that index to the castle and we retrieve the ID. We'll create a state variable to determine if we are showing or not the action sheet. We'll toggle that variable when the user taps on a row, and that's the binding variable we'll be passing to our action sheet. Our action sheets will have two buttons, one to attack and one to fortify. We get a cancel button on the top of the view for free. Our perform player action will do nothing for not for now. We'll just be printing these values. Let's try running this. Okay, and here we have our application with our mock values. We have our list. We can use the digital crown to scroll it. When we tap on one castle, we display the action sheet. Notice the cancel button. We can tap on fortify and attack. And our scene is ready now using the use cases. Now let's hook up the use cases to services. Just like with the iOS app, our Kingdom service will have two publishers, one for the gold and another one for the castles. Additionally, we will have a method to update the source of truth with a kingdom. Now our use cases that return a publisher can, instead of just mocking it, can return the publisher from the Kingdom service. Now that we have everything hooked up to a source of truth, we are ready to start implementing the watch phone synchronization. For that, we will start with a shared folder. Here we will add a file that will have all of the constants that represent the strings where we're going to be communicating information back and forth. We'll have one variable to represent the context key, which is the information that is passed from the phone to the watch. Then we'll have two more constants, one for the castle ID and another one for the action, which is performed on the watch. For the action, we're going to create an enum that represents the action. So far, we can attack or fortify. Having now the keys to communicate with the watch, what we need is a use case that will start this session with the watch. So in this use case, we need to import watch connectivity. Then when we execute, what do we need to do? We first need to check if a session is supported. If it is, then we use the default instance of the session to activate it. And then we need to assign a delegate. Now this delegate will be this use case. In order to conform to session delegate, we also need to be an NS object. So let's add that. And here are the required methods of that protocol. What we care here is that when the session is activated, we will start syncing, as in the phone will update the watch context, but this will also be in charge of listening to the messages passed by the watch application. And we're going to do that through the did receive message. Here is where our connectivity constants will come into play. We'll check the message payload to see if the action and the castle ID values are in. After getting the values from the message, we'll use our perform player action use case to execute either the attack or the fortification. Since we didn't incorporate the logic of turns in the WatchApp, we need to check in this use case if the player is actually in a state where he can choose action, else we will just ignore what is being passed by the watch. To sync the application context, we'll use another use case. To help with things here, I'm going to expose a new publisher in the Kingdom service, which will be just for the Kingdom, regardless of if the update happened with the castle or the gold. Every time we get an update from the kingdom, we'll update the application context of the watch. To do this, we also use default, the shared instance of this session, and for that we need to pass in a dictionary. So what we are going to do in this method is grab our kingdom, transform it into data, and then into a dictionary. And that's it for the sync use case. All that we need to do is execute it when we activate the watch session. And same goes for this use case. The start watch session will be executed by the app delegate when the application launches. With this, our phone implementation is ready. Now we need to do something similarly in the watch side. We're going to start by creating a use case that will start the WC session. Just like we did on the iPhone side, we'll activate the session and also assign a delegate. Notice here that the required implementation of the protocol in the watch side only has the activation did complete with state. We're not interested in knowing when the session was activated. Instead, we will be listening to this did receive application context. Here we will use the connectivity constants to retrieve the dictionary of the kingdom. We will transform it into data, and then we will decode it into a kingdom object. So every time the phone updates the application context, the watch will decode this kingdom object, and then it will call the kingdom service update method to update the source of truth in the watch. Now all that's left is executing this use case. We don't have an app delegate here, so we're going to be creating a view model in the app, and from there we'll call this use case in the initializer. With this, we're good to go. Let's try. Hmm, our application in the watch isn't updating. Oh, I know what's happening. If you look at the upper right corner, we will have two purple exclamation marks. This is because we're updating the view on a background thread. To fix this, we just need to add a receive on to our before our sync methods, and then we use the run loop main so that everything is executed in the main thread. Let's try again. Let's perform something that will update our kingdom, like attacking, and we'll see how this change is reflected on the watch now. Right now, if we tap on the castle and perform an action, remember that we're just printing something, so yes, we're just fortifying, but we're ready from the phone side where everything that we do is getting the application context updated in the watch. So when we're attacking or fortifying, we need to send a message to the phone that is a dictionary. Since we're sending something from the watch to the phone, we need to check if the other part is reachable. We do that through the session. If it is, then we can build the message and send it. Let's try it now. So let's update the context on the phone. That'll get the kingdom updated in the watch. Let's select a castle to attack. And we'll see how this is reflected on the phone. We got the message and we performed the attack with the use case. Also, the context was again updated on the watch side. Since the WatchApp is the same, I'm not going to do this in a different video for the SwiftUI iOS app. So what we're going to do is basically copy what we just implemented in UIKit and add it to the SwiftUI implementation. We'll copy the two new use cases and add the new methods to the turn and kingdom service. Since here we have another SwiftUI app and we don't have an application delegate, just like we did in the WatchApp, we're gonna start syncing in the initializer of the app view model. One thing that I forgot to add in the UIKit implementation is when updating the context, the watch is not necessarily always reachable. So that's one thing that each time that we're updating the context, I need to check with the session if the device that I'm updating, in this case the watch, is reachable. I'm going to be using a different iPhone simulator for this. Just like with real devices, make sure that your simulator is paired with the watch simulator. You can do that by going into the simulator window and checking that. And now our SwiftUI app can also sync with the WatchApp. Reaction is synced, and we're good. And that was all for today. Syncing with the watch can be complicated if you're not careful when separating your sources of truth. Using Combine and use cases, it was really easy to keep everything organized on the watch, and then adapting that in the phone was just a matter of a few lines of code. Hope you liked it. Bye.